All right, Assalamualaikum. Very good day. GIM 212 Statistical Methods e-lecture series. We're still in the ANOVA, Analysis of Variance, and today I will discuss the post hoc test. Okay, the second post hoc test, which is a Tukey test. All right. So this is Tukey test. Okay, the test will compare two means at a time. Okay, just like chef test, but so the difference between chef test and a Tukey test is for Tukey test the sample size must equal. Okay, if you compare the mean between three groups, the sample size for each group must equal. Then you can proceed with Tukey test. Otherwise, you have to use chef test. Okay, so you have to list all possible of combination of means just like chef test, and this is the formula for Tukey test. Q is equal to x bar I minus x bar j divided by square root of MSW divided by n, where x bar I and x bar j are the means of the samples being compared, and n is the sample size. Okay, since we have the equal number of sample size for each group, meaning that n is the sample size for each group. Okay, so how to proceed with Tukey test. This is the first example that we have discussed in analysis of variance, and we have made the conclusion that we reject H naught, meaning that there are significantly different of mean between groups. And now we want to compare which mean are significantly different. And by using Tukey test, you have to compare one by one. Okay, let's say for medication, so this is the first group. The second group is exercise, and the third group is diet. And the mean for the first group, x bar 1, is equal to 11.8. The mean for the second group, x bar 2, is equal to 3.8. And the mean for the third group is equal to 7.6. Okay, actually we already obtained all this information in previous lecture, and now to use Tukey test, you have to calculate the test statistic Q for each pair. Okay, for the first pair, you compare the mean between the first group and the mean between the second group. Okay, between medication and exercise. So Q is equal to x bar 1 minus x bar 2 divided by square root of MSW divided by n. So this is equal to x bar 1 is 11.8 minus x bar 2 is 3.8, and all this divided by square root of MSW for this example is 8.73 divided by the number of sample in each group is 5. Okay, so simplify this, and the answer is 6.06. So this is for the first pair between between the first group and also the second group. The second comparison is between the second group, x bar 2, and the third group, x bar 3. So Q is equal to x bar 2 minus x bar 3 divided by square root of MSW divided by n. So this is equal to x bar 2 is 3.8 minus x bar 3 is 7.6. And all this divided by square root of MSW 8.73 divided by 5. And this is equal to 3.18. And now we have to do the last comparison, which is between medication x bar 1 and also the diet x bar 3. So Q is equal to x bar 1 minus x bar 3 divided by square root of MSW divided by N. So this is equal to x bar 1 11.8 minus x bar 3 7.6 divided by square root of MSW 8.73 divided by the number of sample in each group is 5. So this is equal to negative 2.88. Okay, so now we already obtained the test statistics for each pairs. Okay, now we have to compare with the critical value for the Tukey test. Okay, how to find the critical value for Tukey test? So you refer to the table N. Okay, in the textbooks, you can use table N, critical value for Tukey test. Okay, for the column, okay, column is the number of groups or treatment, and for for the first column is the degree of freedom within group. Okay, and for the first row is a number of groups or treatment. So for this example, okay, the number of groups or treatment is 3, and this is actually degree of freedom within group. So you refer back to the analysis of variance. Okay, degree of freedom within group is the degree of freedom for denominator. Okay, degree of freedom for denominator for this example is 12. Okay, so this is your critical value. Okay, critical value is 3.77. Okay, 3.77. Okay, so now critical value is 3.77. Okay, 3.77. Then if the test statistic is greater than 3.77, meaning that there are significantly different of mean between groups. Okay, for the third comparison, negative 2.88 is somewhere here, negative 2.88, which is not in the critical region, meaning that there's no significantly different of mean between the first group and the third group. Okay, for second comparison, 3.18 is somewhere here, 3.18, which is also not in the critical region, which is there's no significant difference of mean between the second group and the third group. And for the first comparison, 6.06 is somewhere here, 6.06, which is in the critical region, meaning that there are significant difference of mean between the first group and the second group. Okay, so x bar 1 and x bar 2 are significantly different. So the results exactly the same. Okay, the conclusion. Okay, the conclusion is exactly the same with what we discussed in the chef test. Okay, in the chef test, we also find that x bar 1 and x bar 2 are significantly different. Okay, so this is how to calculate the test statistics for Tukey test, and also how to find the critical value before you can make the comparison and make the conclusion. Okay, for the second example. Okay, the second example, in ANOVA, a research organization about tasting the blender with different watts. Okay, now in our previous lecture, we reject H naught. Okay, and we conclude that there are significantly different of mean between these three groups. But now you want to know which group are significant, which means are significantly different. Okay, but unfortunately, the sample size are different. Okay, the sample size in the first group is 5. The sample size for the second group is 6, and the sample size for the third group is 5. Meaning that we cannot use the Tukey test. Okay, because the condition, okay, for the Tukey test is the number of sample in each groups must equal. Okay, so if in exams, or maybe you try any example, if you reject H naught for this kind of samples, okay, which is the number of sample in each group are not equal, then if you want to proceed with post hoc test, you cannot use Tukey test. You must use Schaeffer test. Okay, must use Schaeffer test. Okay, so I think that's all for this lecture for post hoc test. So in next lecture, we will discuss the two-way analysis of variance. Okay, two-way ANOVA. Okay, that's all for now. Thank you very much. Assalamualaikum.